All right, students, so we are looking at some examples, problems of average rate of change and the difference quotient. So we're going to go fast, cover at least one, maybe two of each type here. All right, so first question says find the average rate of change of this function, g of x equals 2x squared plus 8, from x equals 4 to x equals 7. So you can see they've already given us an a and a b, and they've given us a function. If you remember, the average rate of change formula was f of b minus f of a divided by b minus a. So not too difficult. All we have to do is just plug in 7 for b, so g of 7 minus g of 4 divided by 7 minus 4. So when I plug in 7, we have 2 times 7 squared plus 8. That's the first term. Minus, plug in 4, so 2 times 4 squared plus 8. And then all of that's going to be divided by 3. Type that into your calculator, and you get 22. This is the rate of change of this function from 4 to 7. Now, unfortunately, they didn't really give us a context for this. Is this maybe dollars and x is days, or is this the number of products per year or whatever? We don't really know. We don't have any context. So this we're not really able to give any units here. That's a little unfortunate for us. So we'll kind of be like, meh. All right. Here's another problem. Just to look at how we would set that up. Once again, average rate of change of this function from -2 to 2. That's our a, that's our b. So we would plug in 2 h of 2 minus h of -2 divided by 2 minus -2. That takes care of the problems where they give us the formula. Let's look at a situation where they give us a graph and ask us to find the average rate of change. So here we have the graph h, and they say use the graph of the function to find its average rate of change from x equals -5 to x equals -2. Once again, there's our a, there's our b. And let's go ahead and go over here. So when x equals -5, we can go up here, we can see the dot. When x equals -2, we can go right there. There's a couple different ways. We could actually just read that point off. That's a 1 and that's a -2. If you remember, the average rate of change formula was the final y value minus the initial y value. So it'll be h of -2 minus h of 5 over -2 minus -5. You can also think it's the way we came across that formula was that's just the rise over the run. It's the slope between those 2 points, folks. That's really what it is. So that's going down 3, and we're kicking over 3 to the right. So -3 over 3, that's 1. So there's a slope of -1. The average rate of change is -1. All right, we're happy about that. Wanted to go over this problem just because this is a particular situation you might come about. So once again, this is our formula. This is our graph showing our relationship. We're asked to once again find the average rate of change of this function from -6 to -2. So we can see -6 here has a y value of 1, and interestingly enough, -2 has a y value of 1. So you're like, okay, well, has it changed? Oh, it hasn't. The rise is 0. This has not changed at all. The run is 4. So the average rate of change, delta y over delta x, is the rise over the run, 0 over 4. Well, 0. It hasn't changed. We like that. That's a good problem. All right, another type of situation where you might be asked to find the average rate of change might be when you have a table here. So this problem says the number of bacteria in a culture increases rapidly. The table below gives the number n of t of bacteria at a few times t in hours after the moment when n equals 1,000. Okay, so this seems kind of reasonable. Maybe the scientist or the lab technician is kind of checking in periodically, not on a super regular basis, but they're coming in and taking the measurements, or maybe they've got some sort of computer or equipment that's measuring the number of bacteria somehow. So here's the time, here's the number of bacteria. The question that we're asked to find, or the thing that we're asked to calculate here, is find the average rate of change for the number of bacteria from 0 hours to 3.4 hours. Okay, so there's our A, there's our B. And here's our y values that correspond to it. So it's going to be delta n over delta t. So n of 3.4 minus n of 0 over 3.4 minus 0. So y2 minus y1, x2 minus x1. So that change will be 1340 minus 1000 divided by 3.4 minus 0. That gives us 100. If you look at the units here, which is great that we actually have a problem with units, this is this n of t, the n value is measuring the number of bacteria. So we have bacteria in the numerator, and looks like hours in the denominator, so it's going to be 100 bacteria per hour. So I guess you could say, so this is the average rate of change. It might have been, changing a little bit faster at the beginning, and then slower, or slower at the beginning and then faster towards the end. But the average rate of change, the average amount that it changed, is the total change there divided by the time period. And part B just asks the same kind of thing. It's just over a different time period, from 8.5 to 13.6. So there's our final value, 3992. There's our initial value, 2105. Subtract those, and subtract the time values. Final minus initial is going to give you a nice 370 bacteria per hour, and definitely seems to be increasing rapidly. It's only 100 bacteria per hour there, and then now we've got 370 bacteria per hour. So watch out. This thing's going to take over the world here. All right, on to something pretty much pure mathematical here. Let's find the difference quotient, and oh, that's nice, they gave us the difference quotient formula there. F of x plus h minus f of x over h, where h is not equal to 0. Whew, that was a close one. For the function below, f of x equals 2x minus 2. Then they want us to simplify our answer. So f of x plus h means plug in x plus h everywhere you see an x. So here we go. 2 parentheses x plus h minus 2. So that's the first part. Then we've got a minus, so copy the minus down. Then I'm going to copy that's supposed to be a dot, sort of highlighting that. It's not really an equal sign. So f of x, I'm just going to write it again right here. 2x minus 2. That's the f of x. All that divided by h. Then we're going to do some algebra, simplify, and we'll be done. Distributing the 2, we now have 2x plus 2h minus the 2. Distributing this minus, we have minus 2x, and then this minus and that minus turn into a positive, so 2. Noticing we have a minus 2 and a plus 2, which cancel out. Notice we also have a 2x and a minus 2x cancel out, which gives us 2h over h. H divided by h is 1, so we end up with a happy answer of 2 for our difference quotient. Hooray! Now for something a little bit more challenging. Same question, find the difference quotient. There's the formula, but now we have a quadratic trinomial. Alright, let's get out our algebra hats here. So, f of x plus h means plug in x plus h every time you see an x. So, 4 parentheses x plus h squared minus 5 parentheses x plus h minus 6. That's the first term. Copying the minus down because it's part of the formula, then writing f of x over here. That's just going to be 4x squared minus 5x minus 6. All of that divided by h. Time to FOIL, folks. So 4 times x plus h squared is an a plus b quantity squared here. So we have x squared plus 2xh plus h squared. Distributing that minus 5, we have minus 5x minus 5h. Copying that minus 6 down. Distributing this minus, we now have minus 4x squared plus 5x plus 6. Once again, all over h. I think I forgot. So this little open bracket here is supposed to be like after that 6. But okay, anyway. I'm going to distribute that 4 now. So we have 4x squared plus 8xh plus 4h squared. Now, as I'm looking at the rest of this over here, I notice I have a minus 5x and a plus 5x. I have a minus 6 and a plus 6. That makes my life a little bit easier. I now just have a minus 5h and a minus 4x squared in the numerator all over h. And hey, what do you know? Minus 4x squared, or 4x squared and a minus 4x squared. Those will cancel out to 0. So my numerator is just simply an 8xh plus 4h squared minus 5h. I notice that in each one of those terms in the numerator there's an h, so I'll factor them out. There's an h, 8x plus 4h minus 5 all over h. H over h reduces to 1. Final answer, 8x plus 4h minus 5. There we are, difference quotient of this quadratic trinomial in simplest form. stick around long enough, take calculus, we'll be able to do some really neat stuff with this. But for now, we're just happy that we found the difference quotient. And then our final problem, here we go. Difference quotient, once again, this one of a rational. So we're going to plug in x plus h. So we have 1 over, and notice my original formula is 1 over x minus h. So I'm going to say 1 over x plus h minus 8. Copying the minus down there, and then f of x is 1 over x minus 8. All over h. So now, heavy algebra here. I've got two terms, and I need to find a common denominator. And then the simplest common denominator here is just going to be this term times this term. So I'll take my first term here and multiply it by x minus h over x minus h. Or sorry, minus 8. And then this term over here, I'll multiply it by x plus h minus 8 over x plus h minus 8. So the x minus 8 times the 1 is just x minus 8. And I'll go ahead and put that over that common denominator, x minus 8, x plus h minus 8. Then copying the minus down, then we have this term right here times this numerator, x plus h minus 8, all over that denominator, all over h. So I'll distribute that minus to each one of those terms. So I have this x minus 8 minus the x minus the h plus the 8, because that's a minus and a minus there. All over that common denominator, x minus h, x plus h minus 8. And all of that's over h. So I notice in the numerator of the numerator here, I have a minus 8 and a plus 8. I have an x and a minus x. So that numerator of the numerator is just a minus h, or a negative h, if you want to think of it like that. Then this denominator here, x minus 8 times x plus h minus 8. And then notice here, I'm going to do the old trick of fraction of fractions. I'm going to write the numerator, but then instead of saying divided by the denominator, I'm going to say multiplied by the reciprocal of the denominator. So multiplied by 1 over h. That's great, because then those will cancel. Now, when you have something divided by something else, it's 1 over 1 here. So we still have a 1 in the numerator. And I think I forgot that negative. Did I forget that negative? I did. Okay, well, there should be a negative right there, folks. Sorry about that. All right, there we have it. So just as a reminder, we found the difference quotient of this rational function, of a quadratic trinomial, and of a linear function. We also found the average rate of change, looking at a table, looking at a graph, and looking at a formula. So thanks for watching, and good luck solving these problems on your own.